Okay. Let's get started. So before we go to the lecture, I just want to make a quick announcement. I sent a reminder in the Canvas. Please complete assignment 0, which is doing a quick survey by this Friday. This is for trying to document those academic activity for some financial aids from the university. If you go to the assignment, this is assignment 0, and you will see just answer this quick question, right? Basically ask you if you have any background in medical imaging or computer vision. So please do so by this Friday, okay? Okay, so today we are going to talk about reviewing research papers and introduce some of the project ideas. Actually, before I continue, do you guys have any questions, concerns about this course? We talk a lot of details about the syllabus, the requirement, some of the expectations. Any questions, concerns?
Dr. Chen, I have one question.
Yeah.
So, on what days of the week generally the assignments will be due on?
I'm sorry. Can you repeat the question?
Yeah, sure. On what days of the week do we have assignment deadlines? So it's on Monday or Wednesday or some other day?
I haven't, finalized the date yet, but yeah, well, these 3 assignments will kind of span across the semester. So yeah, I will assure you, you have enough time, approximately maybe 1 month for each of the assignment. On those assignments, I will also give you some, helper code because I know some of you may not have much background in deep learning or computer vision. So I'll give you some starter code, right? How to load the data, pre-process the data, and then you can using that to maybe complete the assignment. So I just want to give you a little bit more details. Those 3 assignments were corresponding to one is image classification. So the first one, we actually will do this COVID-19 pneumonia classification, positive or negative. For the second assignment, we will do the liver image, CT image segmentation. So, and the third one will do the image generation using GAN, right? So, yeah.
And about the research papers and the paper readings, we will get 1 week of time, or
Yeah, so yeah, you will have a total of 10 papers to review. I believe, let me see, where did I, yeah. So yeah, I can give you a quick, not all the papers being released, but actually the first one is being released. It's due January 26th. So I just give you guys more time to kind of, because this is the first time you review the paper, just want to give you more time to review that. But after that, it's going to be 1 week each paper, right? You see the deadline here. Every week you have 1 paper to review. So actually for this course, I'll spend a lot of time, give you some recipes or suggestions how you can, review the papers. Once you have those mindset, getting to the rhythm, review the paper won't take too much of the time, okay?
Yeah, sure, thank you.
Okay. All right, so any other questions? Yeah, project, whatever. So before we start. Okay, if not, then let's continue to our part 1, that is how to review research papers. So like I mentioned, there's kind of some of the, recipe you can follow actually, right? So even if you don't, never reviewed a research paper before, right? Maybe you're just starting your graduate school. A rule of thumb, before you reading the paper, you want to ask a couple of questions before you start, right? What are you looking for in this paper, right? So for example, the question you can ask before you start reading the paper could be, what are the motivations for this paper? Okay, and what problems is being solved? And what is the proposed solution, right? What experiment are being designed to kind of evaluate or validate some of the hypotheses, or to validate the effectiveness of the proposed solution, right? And for this kind of evaluation, what kind of metric they are using to kind of maybe compare with other method, to demonstrate the the effectiveness of the proposed solution. And also, what are the contributions, right? So is it doing some, have a new or novel solution, or is some of the propose some new tools or maybe new data set, right? So that will be the contribution of the paper. And what are the potential future directions, right? Maybe does the author discuss some of the potential risk or some of the limitations on method, right? And what is the potential solution or directions can be explored in the future? And also, how is the paper related to what do you previously know, right? So, when if you have some basic knowledge in this domain, then it will help you to connect, right? What do you already know before? And also how the paper is related to other works, right? So in any of the tasks, there's going to be some prior works, right? So how this paper or this method proposed in the paper going to relate it to others, right? Okay, so those are some of the questions you can before you start reading, maybe you in your mind you can go through, have all these questions. Then when you actually dive into the paper, you try to find the answers for these questions. Okay, so usually we can follow this kind of strategy. Maybe the first pass of reading gonna be very quick, right? You don't reading all the paragraphs or all the details. Maybe the first pass, you can first read the title, the abstract, and the conclusion, right? So the title pretty much tells you, okay, what's the problem the author is trying to solve, right? Maybe what kind of method or technique they are trying to use, right? Nowadays, like for image processing or computer vision, usually you will know, or they will put the keywords like deep learning, deep neural network, or maybe vision transformer, etc. GAN, right? General adversarial networks, those keywords in the title. So at least okay, this is the main technique they will use in the paper to solve a problem, okay? Then you can go to the abstract, right? They will, the authors will present, right, what problems are being solved, right? The problem statement, and they will also provide some of the, a brief, a summary of their steps, right? Or maybe the approach, the component of the proposed method. And then you may also get some high-level ideas, right? What's the novel component, right? They will mention in the abstract, and also some takeaway messages, right? Usually, this will contain in the last a couple of sentences in the abstract, right? Maybe they outperform the previous method by how much percentage in terms of accuracy, or they improve the efficiency, as compared to a previous method by how much, times, maybe 10 times efficiency. And also these information can also be found in the conclusion, right? So they usually summarize a couple of takeaways in the conclusion. So by reading these three parts, you pretty much have a rough idea, right? What is this paper about? And, what is the, high-level ideas of their solution. Okay, and then you can also, reading the figures and the tables. Sometimes, a figure is maybe worth 1,000 words, right? So by looking at the figures and some of the tables, you kind of understand, what is the overview of the approach, right? What kind of result are they trying to present? So here I provide an example, which is taken from one of my papers here. Here we are doing, this is a paper doing video anomaly detection. So you want to detect some anomalous actions or behaviors in a video. So this is one picture kind of present the overall pipeline of the proposed approach, right? So even if you don't know anything about video action detection, by looking at, you get a rough idea, right? So for example, for this input, by accompany these video captions, right? You can read it and you kind of idea what's the major step, right? So here, the video is divided into different segments, right? 32 segments. Then each of the segment, go to, or normally will be a positive bag, right? So this bag contains all these segments from the anomaly video, right? You have another stream, right? Do the same temporal segmentation, but in this case, this is a normal video. We consider this as a normal bag, right? So this one will contain those segments from this normal video. Then here, if you don't know anything about neural network, that's totally fine, right? Here, this is like a pre-trained 3D CNN. So, when you read this caption, right, what does this, doing? These network doing is basically doing some feature extraction from these segments. Then once you have that, you have these scores, right? For the positive bag, each segment will have like a anomaly score, like basically how likely this segment is anomaly. Okay, and this one also from the negative bag, this is also have the scores for the segment. Then you will determine, okay, what find the maximum and how likely there's a anomaly segment contained in the entire video. So without knowing all these details, but at least by reading these diagrams and the description of the diagram, you have a general idea what's going on for this entire pipeline. So this is very useful. For the first pass, quickly you kind of know what this paper about. Okay, once you kind of read those title, abstract, conclusion, and scan through those figures and get the rough idea, then you can dive into the details, right? Especially the proposed method, right? For now, then you want to try to understand, right? What are the details of the proposed method, right? Then they may have a section with different subsections describe those detailed components. Okay, and when you're reading those sections, you also want to try to find, right, what's new for the proposed method, right? And what are the motivations if they are proposing some of new technique, right? So these are the very important things when you actually read the paper in detail. Okay, so once you understand the method, then another important piece is you want to see how the method is being evaluated, right? So what data set they are using and what experiment settings and evaluation metrics they are using, to carry out the experiment. And usually they will have tables, numerical result, or maybe also showing figures, maybe, plot the curves, or also figures showing some visual examples, right? If you're doing image classification, usually people report the accuracy, right? The top one accuracy, or maybe the top 5 accuracy. And also, people will also present some visual examples, right? So for image classification, if you have a correct classification cases, you can show that. And you can also show they will also show some failure cases, right? Why the model make a wrong prediction for this particular examples? Is it because these examples are very difficult, right? Maybe there's occlusions, etc. So those are some of the typical ways people will kind of present or analyze their result. So by examining those, you want to ask, are these results convincing, right? Convincing means are they do a very thorough, a good job to evaluate their method, right? Comparing their method with the recent or the latest state-of-the-art method, not just comparing the proposed method with maybe 10 years ago, right? That's not convincing, right? You want to compare the method with the latest, and to demonstrate you are push the state of the art. And also, are the experiment, carried out under the same experiment setting, right? You want to make sure you compare apple to apple, right? Not apple to orange. Then the result is not fair, right? Maybe your setting is different than other people's setting. Then how can you do a fair comparison, right? What the comparison is meaningless. Okay, so those are the things you have to be careful and make sure those details are there. They are very clear and correct. Okay, so here are a couple of articles. You can also read it, and there are some very good suggestions like how you can read these machine learning or vision problem papers. Okay. Okay, any questions so far?
Yes, Professor.
Yeah.
So basically, when we're doing these research assignments, you want us to kind of analyze and break down each paper with regard to like each question that you outlined in the previous slides?
No, I will give you some details, like what is the report going to look like. I give you a specific like sections. I will talk later. Okay, but this is just even you don't want to write a report, right? Maybe beyond this course, right? If you're doing your own research, how do you read a paper? So these are some of the general suggestions or guidelines I want to give to you. But in terms of writing report, which I will discuss with next. So what are the specific things I'm looking for in the report? Okay.
Sure.
Okay. Okay. Yeah. So actually, this is a write a review. So next part is how to write a review on the paper, right? Which each week you will write like a 1-page report for the paper assigned to you. Okay, so here I will give you some of the general guidelines, right? How do you write a review on the paper? So first, you once you read the paper a couple of times, right? You are confident you know everything. Okay, then you wanna starting to write a review, right? First is you wanna summarize, right? What is this paper about, right? Just a couple of sentences to summarize the paper, right? Maybe what problem this paper trying to solve, right? What is the proposed method? Very brief description of the method, and what's the outcome, right? Maybe the paper, getting the new state-of-the-art result, or they improve efficiency, or they introduce a new data set. This is a new benchmark for this community, right? So just a very brief summary about the paper. Okay, then want to also acknowledge the strengths of the paper, right? Unless the paper is total garbage, then there's no strength at all. But more or less, if the paper is going to be the paper are accepted by these top conference, they have merits, right? So we want to acknowledge these merits of the papers, just to give the authors the credit. Okay, so there's a couple of aspects you can kind of mention the strengths, right? The novelty, right? After reading, do you feel like the method proposed in the paper is very novel, right? No one have think about this before, or they present this method in a new point of view or perspective, right? So those are can be considered as the novelty of the paper. Also, is this paper technical correct, right? So you find out like maybe they have, this is a theory paper, right? Then you want to make sure the theory and the proof, everything is correct, right? So they have very rigorous derivation of their proofs or lemmas or whatever. So you want to also acknowledge that. And another, common aspect is the clarity, right? So, which I think this is also very important, right? If the authors cannot present their idea very clear, then it's not a good paper, right? That's the bottom line, right? You want to present your paper, your idea very clearly to the audience, even they don't have any background knowledge in your domain, right? So that's the clarity. And also the experimental evaluation, right? This is also very important, right? If you have all these components, that's good, but how is your method going to play out in the actual maybe real world scenarios, right? So you want to verify that from the experimentation, right? So a major shortage, I would say, is some papers don't do a very comprehensive evaluation. But if you do see, papers do a very comprehensive evaluation, this could be at the strength of the paper, right? So they may evaluate on a multiple, large scale data set, right? Just to test, okay, their method is able to perform consistently better than the other approach, not just handpick like one data set, right? And show the result and they claim, okay, our method is performing better, right? How about the other data set, right? If you test like 2 or 3 at least, then you found the consistent, conclusion, then you can make maybe confident to make a general claim that your method is able to outperform the others, on these popular benchmarks. So these are some of the things you can look for. And if they are doing a good job, you want to also mention this in the strength. Okay, and then we go to the hard part, right? The strengths, you can easily summarize a couple of them from those aspects. The difficulty comes at, the weakness of the paper, right? Because now you have to criticize the paper, right? Be very picky, right? What do you think, what are kind of aspect you think are the weakness of the paper, right? Typically people will trying to criticize on these a few things. One is also the novelty, right? So comparing to the prior work, how novel is the proposed method, right? Is it significantly novel or is just incremental? Okay, I can give you a couple of examples. What can be considered incremental? Okay, directly using a method, for example, you take one existing off-the-shelf technique. For example, you are using one state-of-the-art object detector, for example, YOLO or Fast RCN, and you apply it to do the like a red blood cell detection in these medical images, right? And you present the result, and essentially there's no novelty, right? Because everything, the technical part you are using is existing work, right? Off-the-shelf technique. You're just using that or apply it to a new task or new application, right? So the technical novelty is very little. Another example is, so-called these combination, right? I combine technique A and B and C, right? I mix them up and I get a couple of, I get some improvement of my performance, right? That also consider very incremental novelty because these are just some very simple combination, A plus B plus C, right? We know those maybe 3 components are state of the art. You combine them together, of course, you can improve some of the performance. So that's also like considered the lack of novelty. Okay. Also, another aspect is lack of clarity, which you can easily tell, right? If the author describe their method is very vague, right? A lot of details are missing, or they present in a way is very difficult to understand, then this could be also another weakness, right? Usually, if you are, just think about you are the author, you submit your paper to a conference. Reviewers typically spend like, mostly I would say have a couple of hours read your papers and they want to, write a review and submit, right? If your paper is not very clear, after 1 or 2 times they read the paper, they don't understand what you are trying to do. They got frustrated, right? They lose their patience. Then they can just write something, the paper is very poor organized, poor written, right? It's not very clear. They don't understand what we're trying to say. Then, so that's a big disadvantage of your paper. So, so this is, typically another weakness, maybe you can find for a paper. Okay. Next is the technical error, which is rare. Usually, when the authors, submit a paper, they usually, proofread, examine their like a theory part a couple of times to make sure everything is correct, right? But if you do examine some technical errors, maybe due to typo or something, you definitely want to mention that, correct? The author will appreciate that, okay? And also mismatched experiment design. Maybe the experiment they designed could not, fully justify what their claim or hypothesis, right? So their experiment design may not be appropriate. And also insufficient experiment, right? So like I mentioned before, right? You only did a very simple experiment and you want to trying to make a big claim. So this is also can be considered one weakness of the paper. Also unfair comparison with other methods, right? So if you don't even using the same data set and you compare the result, right? That definitely is not unfair, right? And also, even if you're using the data set, but your settings are different, right? For example, I using 80% of the data set for training, 20% for testing, but the method I'm comparing with is using 50, half and a half, right? 50% for training, 50% for testing, right? Definitely those results is not comparable, right? So you want to look out for, if the settings are fair, the same setting, okay. And also when you write each of the weakness, you want to kind of justify the comment, right? Why do you think it's not novel, right? Maybe you can mention this is incremental because these A and B and C are existing technique. They are just simple combination, right? And maybe it's not clear, right? So some of the parts are missing, or a lot of important information are not there or not described clearly. So you want to justify that. So, the reviewer, the authors will also appreciate that, right? Why do you think their paper has these weaknesses? So they are able to revise and improve their paper based on your comments. Okay. Finally, once you have list those weaknesses you think about the paper, then you want to give your conclusion, right? Your decision about the paper, right? You are the reviewer. What do you think about the paper, right? So is this can be accepted or is just like a, borderline, right? You don't, it won't hurt your feeling if this is rejected or if this is going to be accepted, right? Those are considered borderline paper. And also there are some papers, you want to definitely reject, right? Maybe there's some technical error. The novelty is very weak, right? It's not a good paper to accept. So here I just list the ratings from NeurIPS, one conference, right? They have these different kind of ratings, right? Top 10 papers, right? Very excellent paper, strong accept. Right, then there's top 50, a clear accept, right, a little bit lower than this one, and the good paper accept, right. This is kind of these three are kind of lean towards accepting the paper, right. Here is marginally above the acceptance threshold, right, and then there's a below the threshold, then rejection. Okay, so these are some of the common choice. Okay. And if you are making a rating, let's say you want to reject, you also want to justify that. Why do you think? Why do you reject the paper? Right? Maybe the justification could be there's a couple of critical concerns, right? Maybe the novelty is very weak, and also the experimentation is not very comprehensive, right? Those are some of the big or major limitations of the paper, right? So this will result a rejection. Okay, so just like 1 or 2 sentences to justify, why you are making this kind of decision or rating of the paper. Okay, and this is something I also would like you to think about, although this is not required. Basically just brainstorm some future directions, right? Giving the author some suggestions, right? I think the authors will be very appreciated if the reviewer is able to giving some suggestions or future directions, right? Although reviewer rarely do this because they want to protect some ideas. But for this course purpose, I wanted you to kind of think about this. If you have some ideas, feel free to write it down. Brainstorm some future direction. What do you think? If you have some new ideas, this could be some potential improvement. You can write that down. Okay. So, and also like, if you think this is very promising, you can even try out yourself, right? Maybe you can have a paper out of it. So this is something you can think about. Okay, so here I take some screenshot, like what is the typical review form look like. This is from CVPR, I believe. So, if you're a reviewer, you assign the task for reviewing the paper, right? They'll have like paper ID, the paper title. Then, right, firstly the summary, right? A short summary of the paper and its contributions, right? It's just a couple of sentences to briefly describe that. Then you go to the paper strengths, right? What do you think are the positive aspects of the paper? Then this is the important part, right? Paper weakness. You want to list a couple of them and provide the justification. Okay, and the fourth, you don't have to do this in your report, but this is typically required by reviewer from these conferences. That is the rebuttal request. Because of the review process, after the review, the author get the review feedback. They will have like 1 week to write the rebuttal or response to kind of address some of the comments from the reviewers. So these are some of the comments you can write down, right? What do you want the authors to rebuttal, right? Maybe you want to have some clarification on some points, right? It's not a big deal, but if the author is able to clarify that, you are satisfied, with this point. So you can write some of the comments here, specifically ask the authors to rebuttal on these points. And then, recommendation is like the overall or final rating, right? What do you think this paper, right? Justify your rating. How do you evaluate towards maybe the solution or decision of reject or accept, right? These are the ratings you can select. Okay, and here, if you have some confidential comments, you can put it here, right? Maybe you detect some plagiarism, right? You don't want to embarrass the author, or you want to have a second opinion to verify if this is a plagiarism, right? You can write some comments here to the area chair. So just to bring attention to the area chair, so they can, have another expert to examine the paper to verify if this is the if the comments or issue you raise is true. Okay, but this is optional. Okay, so yeah, those are some of the guidelines I would expect. Before you submit the report, I will give you an example report. So basically you can follow that, which particularly adhere to what I just described, right? So the summary, strengths of the paper, weakness of the paper, what's your overall evaluation of the paper, and what's your justification? Okay. So now I have a question for you. So what do you care the most about a research paper? right? If you're doing research, or you probably will reading papers, a couple of papers every day, right? What do you care the most about a paper? Anyone?
For me, I would say clarity. That's kind of the main thing, is just,
Mhm.
some cohesiveness throughout the entire paper, to be able to actually understand it. 'Cause
Yeah,
sometimes they just get off track or that sort of thing.
right, exactly. Anything else? Yeah, detailed description of the method and how the problem is being solved, right, using the method, right? So yeah, clarity is also right here, right? If it's not clear, then you probably won't able to know like what's going on with their method, right? How it's being solved. So this all kind of leading towards what can you learn from the paper, right? So why we are reading paper is because we want to get some insight from the research paper, which may help your own research, right? Maybe inspire your new ideas, right? So I think that's the most important thing you want to learn from a paper, right? So I say this is because, like, for you, if you want to write, you're doing research, you're writing a paper, I think though that's the important question you want to ask yourself, right? If other people reading my paper, can they learn something, right? Can they get some insight or get some, observations or new ideas from your paper, so they can, maybe apply to their research, or maybe combine with some of their ideas to kind of, make some advancement in the field. So if you have this in your mind, then you want to, present the paper in this way so that people can clearly get those information. Okay. Yeah.
Dr. Chen, actually, I didn't read any research papers till now, but the question that you asked, I can answer it like in a way. I had read many blogs, but the most thing that I care in these blogs is how simple they are and how much clarity they have, and
Mhm.
if they have any code that they have provided with the explanation and with suitable examples, that will be really good in the paper.
Yeah. So yeah, I think that's the art of writing or presenting your paper, right? So I see if you read a lot of papers, I think one common, or maybe not very common, I guess, one mistake people may do is trying to make their method looks fancy, right? They introduce a lot of mathematical equations or derivations or proof, which may not be necessary, but kind of make their paper looks very fancy, right? You have a lot of equations, right? You have a lot of theories, but are those really necessary? That's the question, right? Maybe the theory is well known, right? Why do you need to redo these in your paper, right? You can just cite it. If readers are interested, they can go to that original paper and get some ideas what the theory about, right? Rather than put everything, those very details, dump every details in the paper, which make the paper very complicated. And you can easily get lost, right? What's the key point, all right, of your method, right? What is your key selling point? So yeah, so those are the things, how, making your method, easy to understand. And so that's really important. Yeah.
And Dr. one more question. How important do you think is going through the code of the research paper?
Yeah, so that's a very good question. So actually, my suggestion is, if the paper you are reading that's you are very interested in, and they are maybe very relevant to your research, or maybe you think there are some ideas maybe I can use for my research, I definitely suggest you kind of look into their code, because a lot of details they may not put in the paper. If you think about, most of the papers, they are like 8 pages, right? and they have like introduction, related work, right? They have to present the result, experimentation. Those parts are usually take a lot of spaces, right? Usually when you look at the, the methodology part, they usually occupy maybe 2 at most like 3 pages of the entire, paper. So on those 2 or 3 pages, it's very difficult to mention every little details of their method, right? Sometimes they just put the very important ones in their paper, so you get a rough idea. If you really want to get at the bottom of the method, know every detail of all the method, so you can reproduce or maybe take that and do some modification, you should go to their code, examine the code and how each component is being implemented or realized. So that's my suggestion for you. Okay.
Yeah, thank you, Dr. Chen.
Yeah. Okay, so the next part will be presenting the research paper, right? So that's the other part we will do. So you will assign the paper, then you are presenting this paper in class to the audience. So first of all, your audience will be your classmates, right, for this course, and you want to explain and discuss the paper, right? Assuming no one in the class has read the paper before, right? So how you are able to present, the problem, the methodology of the paper clearly to the audience. Okay. So here are some of the suggestions I have, for you to make a good presentation. You can follow this kind of paradigm or preparation to when you prepare your presentations. First, write the title of the paper, right, the author, institution, so people get some basic ideas where this paper come from. And also, then you can have a couple of slides, tell like what's the research problem, right, the problem statement, and what's the motivation of this research, right? Is this problem being solved? Very important or trending topic. So that's, the first couple of slides, you want to describe the problem. And then you can go to the main contributions of the paper, right? So a new method, or the improving or extending existing method, or they are, compared to several popular papers, they did something and do a very thorough benchmark, right? Or are they presenting a new theories, or maybe proposed a new data set and do a very thorough benchmarking on this new data set, right? So these are some of the contributions you can summarize just to let the audience know, okay, these are the main contributions. And so these can be some of the arrangement, right? So so I also want to make a note on the problem statement. It also be helpful if you think, this problem may be a little bit difficult to understand or requires some of the background knowledge. It will be good, you can prepare more slides to kind of lay the background knowledge about the problem, right? Maybe they're using some other techniques in other field. Maybe you want to lay some foundation or background, just to ease, towards like the later when you introduce the, problem, the methodology. So I think that will be very helpful. Okay. And then you will do the approach outline, right? Maybe you can take the figure, if they have like a figure that demonstrate the overview, you can take that figure and put it here, trying to explain like what's the high level idea of the approach, right? Then you can, go to the details or describe each of the components of their approach, right? With some detailed techniques. And then we'll go to the experiment, right? So the data set, what kind of experiment they are doing, the baseline method they are used to do the comparison, and evaluation metrics, right? And also some, key results, right? You can put tables, figures, trying to highlight, what is the results on these data set. And you can also mention some of the related work, right? You know, how this is related to some of the prior or existing works. And also 1 or 2 slides to summarize some of the take-home messages. Okay. Then you can, you know, present some of the, what do you think the strengths, the weakness of the paper, just like you're reviewing it, right? And, you know, and also you can, you know, say, if there are some ideas like what can be improved, you can also mention that, right? The future directions, okay. Here, I suggest you go look at or go to these YouTube channels because a lot of like CVPR, ICCV papers, they have the actual author presenting the paper, right? You can learn from them, right? How they are presenting their paper. So I suggest you maybe get, you know, look at a few of them to get some ideas how people presenting their papers. So you have some basic idea, so you can do, you know, do this similarly. Okay. So I already have a list of papers for presentation in Canvas. It's not available yet. So let's quickly show you here. So here I have a list of papers that is related to medical image computing using deep learning. So I kind of categorize them into different topics, right? Segmentation, detection in medical images, biomedical image processing, like registration, reconstruction. There's also visual text processing, right? You want to generate some medical report based on the image. There's also federated learning for medical image computing, label efficient learning, and adversarial, you know, learning model robustness of the model, and also some other miscellaneous topics like introduce new data set, surgical video analysis, you know, etc. So this will be available once you know, the class roster is finalized. So I'll release that probably next week. So you guys can, I will have those detailed instructions. So each one you can select one from them, then you have enough time to prepare this presentation, okay? Yeah, that's fine. So you don't have to choose the same topic. But I purposely have like 35 papers in total. So I think at least, you know, we will cover a couple of different topics. So yeah, you don't have to, you know, choose one from a separate topic. Say if you're interested in segmentation, there's a couple of choices, right? Maybe 5 or 6 papers. Maybe multiple students can choose papers from that category, but each one paper can only be you know, reviewed once, right? If one paper is claimed by other student, you have to select the other ones. Okay, first come, first serve. Okay, any questions so far? Okay, so if not, don't have any questions, then we'll talk about the project. Okay. So the project is different than the programming assignment. So the project, you have the freedom to propose your own project, you know, ideas or problems. But it has to be, you know, medical image analysis and using deep learning method, because this is the trend. I wanted you to learn deep learning method from this course, okay? So here I give you a couple of example ideas. So maybe if you're interested, you can pick one of them, or maybe you can modify them, or, you know, get inspired by these topics and propose your own. Okay, so the first one is this interactive segmentation. So interactive means involving human in the loop, right? Usually the non-interactive means we have a training data and we have the labels, right? We do supervise the training, and once your model is trained, you can do the testing. Okay, so for the interactive is, human can in the loop, right? You can, using these click, right? This is the most popular way to label, right? Maybe you click here, label this as a ball, right? The pixel belongs to the ball, or maybe click here, this pixel belongs to the apple, okay? Then your model is kind of able to, based on your input, or a trained model is able to, based on your the new input, kind of refine the model and generate these masks, right? And you can also correct the segmentations generate or predicted by your model, right? If your model generates a segmentation map, there are some clear errors maybe on the boundary, right? Then you can click that and correct that label, so your model can be refined. So actually this is very useful for medical image segmentation, because a lot of time those like MRI, CT images, those organs or regions are very complicated, right? So a lot of boundary regions are not very crisp clear. So the machine learning model may make some mistakes on those regions. So if a radiologist or AI machine learning algorithm involved, and human can make some correction on those difficult regions, then the model is able to learn better over the time. Okay, but this interactive segmentation is not like a human has to label every pixels, right? You just label just one or two using very simple click, and the model is able to kind of refine the model. Okay. So here are a couple of source I provide, so you can take a look at it. So actually this method is already doing medical image segmentation. So this could be your starting point you can think about. So they have the code available, and I also have some reference. You can have the topic of interactive image segmentation. Okay. The second topic could be the MRI brain tumor segmentation, which is very popular task in medical image computing. This is using the MRI brain tumor, MRI image to segment the brain tumors. Okay, so this is a competition held annually for the MICAI conference. So I think you can consider this is a competition, right? Because they have the leaderboard. You can, submit a result on the server and get, how are you ranked in terms of your result. So basically, the task will do some segmentations, right? You have different tumor regions, and you want to develop like deep learning algorithm to segment those different tumor regions. Okay. So for the programming assignment 2, we will do the segmentation, right? So once you did that, you're pretty much familiar with how segmentation works, right? If you are doing this as your final project, that will be, I won't think will be a problem, because you already practiced that on the programming assignment 2, okay? Okay, so here I also have some of the helper code already, which is actually my paper here. So we also have the code available. So how to load the data, pre-process the data, how to compute the evaluation metrics to generate the result outcome. So you can, using this, leverage this as an example and develop your own algorithm. Okay. One thing I want to note is that the data set for this brain tumor segmentation, you have to send a request, submit a form, send a request. So go to this link. If you are interested in doing this project, go to this link and send a request. Once approved, they usually will approve like within maybe 2 or 3 days. So then they will have the link to access the data set. Okay. So here are a couple of references you can look into, maybe develop your own algorithm. Okay. This one, it's not like strictly like considered like medical images, but I think this is a very interesting problem doing this pill image classification. So we can say this is kind of healthcare or medical related. So this is actually one challenge sponsored by National Institute of Health, NIH. So they have different pills styles, shapes, right? I just give a couple of examples. So you want to develop a deep learning algorithm that is automatically identify these different pill types. So actually, I think this is very useful. Especially for the nurse or maybe pharmacist, right? They may examine or select these the pills manually. But if you're able to have a machine learning or AI algorithm that is able to automatically recognize and categorize these pills, I think that would be very useful, at least able to save some intensive labor. Okay, so here are some of the data set and some of the resources you can use. So basically, you can develop like state-of-the-art deep learning algorithm to achieve very high accuracy on the pill classification. Okay, so I just mentioned a couple of them. I also provide like a PDF on maybe 2 or 3 additional topics, like for the COVID pneumonia classification or the blood cell classification topics. So you can also look at the PDF, which is already available in Canvas. Okay. But you can also, other resources to look for project ideas. Okay, one is maybe you can look for these, top medical image computing conferences and see if there's any topic you are interested in. So let's just quick look at it. Okay. So here is the MICAI 2021. So they have a list of accepted papers. So if you click like by topics, right? So which is where we have right now. You can see they have these topics. Let me blow this up a little bit. So you can see there's a clinical applications, right? Breast, cardiac, dermatology, video imaging, etc. Lung applications, musculoskeleton, right? So they kind of list different topics and based on different applications. And then there's also, if you're interested in doing something image reconstruction, maybe related to your research, you can click that, right? So these are some of the papers related to image reconstruction. You can get some, maybe briefly go over these papers. And, for one thing, you can identify the topic you want to do. Maybe you want to do some vessel reconstruction, right? You can look at the paper and figure out what kind of data set they use. Maybe you can use in the same data set, follow the same setting and do your experiment, right? So let's say you are interested in image segmentation, right? All these are the papers related to segmentation, but maybe for different type of image modalities, right? CT, MRI, X-ray, or for different applications, right? Lung, liver, heart, brain, whatever. So you can look at these papers and, find one that you are interested in, look at the paper, get the data, figure out what data set you can use and what kind of evaluation you can follow to formulate your project. Okay, so actually a lot of topics you can follow here, right? If you are interested in doing some pure machine learning, right, you have these domain adaptation, interpretability, reinforcement learning, self-supervised learning, semi-supervised learning, machine learning uncertainty, etc. Okay, so yeah, so also if you are interested, I remember I think one student last time mentioned they are interested, he or she interested in EEG. Okay, so here here you go. So these are the papers related to EEG or ECG, right? So you can look at that, right? Maybe to, evaluate the sleep stage, right? You can using that, okay? Okay, another very good resource is look at the conference workshops, right? So Mikai, they have workshops, specific workshop. Let's look at that as well. Okay, so this is an example for Mikai 2021, right? Workshops, it's different than the main conference, right? Workshop is like a small, like 1 day or half day session that has a particular focus, right? If you look at the title, right, that is simplifying medical ultrasound. Maybe this workshop is specifically dedicated to ultrasound processing, right? And this one is predict intelligence in medicine. Maybe they are, centered around this topic. And this gamma contest, right? So they have different topics for different workshop, right? Brain lesion workshop. This is for the brain MRI segmentation I mentioned before. So yeah, this is also very good source to look for some ideas, right? So usually the workshop, they will list a couple of topics. They will host competitions, right? Competitions means you can find the data set, what exactly the setting you want to evaluate, and you can get the result comparison, okay? So yeah, here are a couple of them, which is related to medical image analysis. So you can, feel free to check them out and, see if there's anything topics you are interested in, okay? Another source is the Kaggle competition, right? So on the Kaggle website, you can type like keywords like medical, then you can find some of the data set you want to maybe use, okay? And also ideas inspired by the papers you read, right? So we're gonna read the paper every week, right? So if some of the paper you are interested in, after you reviewing it, you have some ideas, to further improve, then you can do that, right? But one suggestion for you, if you are going for this route, is maybe the papers you read have some, they have the code released, right? Then you can easily kind of improve upon that, right? So you don't have to reinvent the wheel, right? So you have to re-implement their method. Maybe sometime you didn't implement them correctly, so you don't expect, you don't get the expected result, right? So it'd be a good idea to have a paper that has source code available, and then you can build based upon that, okay? And finally, I would encourage you to kind of think about these project ideas that are related to your research, okay? So if you're doing master thesis or doing PhD, then you want to try to formulate something that is useful for your research, okay? For example, if you're doing PhD, you are focused on maybe adversarial learning, right? Adversarial robustness of the model, okay? Maybe you develop some general deep learning or machine learning algorithm towards these adversarial robustness. And one test bed you can try is test your method on medical image data set, right? So this is also very relevant to your research. Another example, maybe, let's say you are coming from mechanical engineering, right? You are doing some surgical robot, right? Maybe one component for you to developing the surgical robot is the sensing part, right? You using cameras to do sensing, right? Get the images or videos, then you want to do some processing, right? Maybe detect or recognize the surgical tools, right? This is a scissor, this is another, maybe another type of surgical tools. And you also maybe want to segment maybe some images. So then using that information later to, kind of to develop the control algorithm, right? So those are something you can think about, right? How you can relate your research and maybe make this course useful, okay? Okay, so for data set, here are a couple of very useful resources. So very comprehensive. So you basically can find, you know, pretty much all the medical image data set on these repository. Okay, and also these computer vision online, they also organize one category that is for medical images. Okay. If still you cannot find the data set you want to use, you can try like a Google dataset search or Kaggle dataset search. Okay, you can do that by yourself. Okay, so for your project, so first you want to take some time to think about what do you want to do, right? So you want to develop a proposal, okay? So for this proposal, I want you to state like what's the problem you're trying to solve, right? What's the motivation behind the problem, right? Like I already make a couple of examples, right? For example, the surgical, you know, if you do some develop some surgical robots, right? Sensing using vision is one part of it, right? So that could be your motivation, right? You are doing this for this course project, okay? And your proposed approach and how it relates to some prior works, okay? And what kind of experiment you plan to conduct, right? These are pretty much you can find on some existing papers, right? Relevant works, right? You can just follow those experiment settings. What data set, how you're gonna evaluate, right? Okay, so yeah, this project proposal is due February 4th. Okay, so you still have a couple of weeks to think about that. You know, kind of trying to, you know, carefully formulate the proposal you want to develop. Okay. And we also have this project milestone report in the middle of the probably later part of the semester. Basically, this is kind of want to show like what kind of result you already achieved, right? Based on the proposal you have, right? You have a plan, right? How you're going to do the experiment. So then by this time, what kind of result you already achieved, right? So some parameter set of result and some analysis of the result. Okay, maybe at this point, you have the result, but the result is not as good as you thought it would be, right? Based on the analysis, right? Then you can think about how can you improve, or maybe you have to, you know, debug your program. Maybe there's some errors or bugs there. You have to maybe fine tune your model parameters to improve the result, right? So additional experiment that you plan to run, okay? So I enforce this milestone report is I want you to do this project, you know, early, right? Don't wait till like the last, you know, 1 or 2 weeks and do this project. You may encounter some of the difficulties that you cannot solve within 1 or 2 weeks. So you want to plan this project like the whole semester, right? Maybe do something little by little every week. So by this time, you already have a lot of results ready. So you just have to do some final touch of your experiments, okay? Or maybe, you know, crack something, you know, do some more analysis by this point, okay? This is due April 8th. And finally is your, the final report, right? Basically, you can extend your project milestone report to include some of the final set of result, right? So note that, you know, these 3 reports is like not like is not treated like 3 separate ones, right? You kind of build one by one, right? You first is proposal, then your milestone is based on the proposal. Then the final report is, it can be based on your milestone report, right? Just keep adding stuff to the report, okay? Okay, so one thing I have to absolutely make sure, you know, you also want to make sure is that if you leverage some existing source code, you should state that in the report, okay? I'm not against you using existing source code on GitHub, whatever, it's totally fine. You know, save some time to like, you know, coding or program from scratch. That's totally understandable. you can use that, but you have to, you know, acknowledge that, or credit or cite the original author, the source in your report, and also in your code, okay? You want to make sure you credit the original source, okay? This is very important. And also identify which part is your own work, okay? You cannot just take the GitHub repo and run it. If it's successful, and then take that as your final project. It's not acceptable. So you basically just run someone else's code, and it is working, then you write a report on that. It's not acceptable, okay? Here, replicating one project is not acceptable, okay? You have to at least make some changes, right? The simple way is, can you switch the network or maybe make some modifications based on that? And so then you'll have your own part, right? Okay, so the final report is due May 2nd, okay? And all these deadlines are final, okay? Any questions? Okay. Yeah, so this one, writing the your final report, which pretty much you can you know, take what you learn from reading the paper. So I don't have to reiterate everything. So, but basically this is some of the general guidelines. I also provide a template for you guys. You know, when you submitting those reports, I already provide those templates, so you can follow that. Okay. And yeah, so if you also want to learn more, all right, if you're aiming very high, you want to, you know, eventually maybe publish a paper for this final project, you know, this is a very good talk. I mean, the, you know, suggestions by Professor William Freeman from MIT, you know, how to write a good CVPR submission. So you can follow some of the suggestions there. Okay. Okay, finally, I have some questions for you. The first one is, how do you quickly know a research topic? Okay, say you want to do medical image segmentation. Maybe this is the first time you've even gets your hands on this topic. How do you quickly, you know, equip yourself with the basic knowledge?
I have a suggestion.
Yeah.
So how I would personally do it, I don't know if this is the answer you're looking for, but I would try to find someone that I know that is more familiar and have them suggest whatever they think are the most important papers. And then once in reading those papers, I would focus especially on actually the introduction and related works, because that sort of says, like, this is a milestone paper, and here's the state of this area before the introduction of this milestone. So that gives you a sense of the field before and after this paper.
Exactly. So that's a very good suggestion. So I would also recommend you guys to do this. You know, find a very influential or maybe very popular paper, right? Read the introduction, related work. So just to get some idea. Another way is to find a survey paper on this topic, right? If there's a survey, if you are working on a very popular topic, there must be some survey papers out there, right? So you can look at the survey paper. You know, survey paper is usually very comprehensive, right? They kind of review, what's going on for the past 20 or maybe even 50 years, right? How the field is being evolved over the time, right? What are the major in the mainstream techniques or different categories of techniques being used to solve the problem? And what are the data set being used, and what are the evaluation technique, and what are the state of the art right now, right? So you gotta have a very quick overview of this field. Then you can try to nail down a couple of very latest or recent milestone papers to focus on, okay? And how do you find the state of the art method for comparison your experiment? That's the second question, right? Because, you know, if you do your own project, let's say you develop a new algorithm, right? How do you find method to compare with. Okay, so I think one quick way is, again, you can find like the one latest paper, right? Let me show you actually. So say I'm doing brain tumor segmentation, right? So I actually know my paper is published in 2022, okay? So one way, if this is a very popular paper, so you can put in the Google Scholar, okay? And, click check here, right? This is the paper and it's being cited 22 times, right? Click that. Okay, so these are the papers all cite that paper, my paper, right? So these are all recent ones. So if they cite your paper, they must doing something similar, or they do on the same topic, right? These are considered very relevant papers. So you can quickly, scan through these titles, right? If they are doing, these brain tumor segmentation, if they are, then you can check their papers and see what's their result. Okay, so if you check this paper, right, this is like 2022. When you do the comparison, you don't have to like re-implement every algorithm yourself, right? As long as you follow the same experiment setting on the same data set, you can take the result from this table, okay? Right, so because you're doing the same, you're using the same data set, follow the same experiment setting, right? These are the result people reported under the same data set, same setting, that's the result, right? Then you can, look at these, select the recent state of the art and compare your method with these results, okay? So you don't have to like re-implement a couple of other methods, which is very time consuming. So that's why I kind of emphasize, right? You want to follow the same setting using the same data set, right? To do the fair comparison and also give you the advantage of, you can take some of the already result reported in their paper, okay? All right, so I think that's it all for today. Before I end the class, do you guys have any other questions? Yeah, so I think Kyle made a very good suggestion. They have this website to visualize the relation between citations. Okay, yeah, so this is the link. I think everyone have this link, right? So maybe you guys can check that out and see if this is useful, okay? Any other questions? All right, if not, we're gonna end here. All right, thank you everyone for attending the meeting. I'll see you next week, okay? All right, have a good weekend.